So let's open the grasshopper sample file I will share with you guys. And the first one is 01 heating system used before. I also attached the complete grasshopper file. So we can just open this file 01 heating before. Here because I'm not gonna get into the details for the geometry in the heating load or schedule setting up. I'm just using a very simple geometry here, which is one zone, and I'm not gonna create a unit heater system and assign the system to this model, to this room. And I'm gonna use the default, the New York City weather file, EPW file as a inside in our demo. You can set open the EPW map to download your own city to test this model. And let's get started. So once you install the Pollination Grasshopper plugin, you can see the Ironbug plugin is installed along with all other Liba tools. You can see here, there's the Ironbug. Someone probably doesn't is showing icon mode. You can right click the tab and switch display as text. Now it's a text. Display, right click again, display as icons. So it will show the tab as icons. It's easier to find one. Now, first of all, let's make a thermal zone first, because right now it's a room, a honeybee room. So underneath the first tab, the thermal zone. And let's connect the thermal zone from the room to honeybee rooms input. Here you can see you can assign the air terminals and the zone equipment, because we are going to, as I mentioned previously, this unit heater is a zone equipment in this case. And because we have a ton of the HVAC components, it's a bit hard to find what you want, because I know it's underneath the zone equipment. It's probably somewhere zone unit heater. We can just double click the grasshopper canvas and type in unit heater. Oh, unit heater. And you can see the system here. You can see. So this input, it shows it can be 3 different types: coil heating water, coil heating electric, coil heating gas. Now let's just use the simplest coil heating electric, which is over here. Coil heating electric, and connect to the coil. And the fan, we can just use fan system model. Just use this default one first. We will set up the later directly for a more detailed setting. And assign this unit heater to zone equipment. Okay. Now we have one unit heater added to the thermal zone. The next step, let's go to the last tab. Here is the HVAC system. Let's bring that down to the canvas, because the input here is the loops, air loop, plan loop, or VRF system. And if we connect to this, will complain because it's not an air loop or zone, it's not a loop. But what if we have one zone that doesn't really need any air loops? We can bring down this no air loop component, which means these zones doesn't need an air loop. They only contains zone equipment. Once we have this done, we have the most part of the Ironbug system ready. Now let's go back to the Honeybee side. Underneath the HVAC number 4 HVAC tab, you can see there is a detailed HVAC. So the room is a Honeybee object. The HVAC system is the HVAC system. And okay, because I'm using developer version, it's complaining about the version, but this should be fine. On your machine, if you install the Ironbug with pollination grasshopper plugin, this error won't show up. And then now let's try to run the simulation. Model, let's build the model. HB model, with looms and the model, the EPW file. EPW file, we have to download it first. Download the weather. EPW file. And let's do a test run. Because this is a single zone model, it runs pretty fast. Now we can check the result. Into the EUI SQL file. And what's the EUI? Here 104, and the unit is kilowatt hour per square meter. And use okay. Control F, bring to the front. All right. Now we have the systems ready. So the simulation runs. It's fine, right? But how can we make sure this runs correctly? So one thing, the first thing I think we have to check is unmet hour. So let me check. One way to check unmet hour is from the EPW, from the HTML file that generates from the. If you search unmet hour, here, the heating cycle degree. So because right now we only have a heating system inside the building. So I believe because here is showing the degree hours, but I wanna only 1 hours is comfort. I'm not comfortable based on okay. I think it's this one. Time set point not met. So because we have a set point during the heating season, we have 0 hours. The system doesn't meet the set point. You can say this took me some time. If you're familiar with this title here, you can just search it directly once you open the HTML file. But I prefer to do that everything inside the Grasshopper. So one way we can do is we can try to open up the RDD file. This RDD file, we can just read file. We can see there is a zone comfort or something. Surface. No as system sensible heating rate. Zone. Yeah. Zone heating set point. No map type. So we just need to type in zone heating set point. Not map type. I probably wanna for the most of the case, we also want the cooling time as well. So I'll just type in that. So I'll just copy. It's cooling. Cooling. Okay. And of course, we can get a full entire building's heating set point. But for detailed analysis, we want to check the room by room. This is zone by zone here. And now we have the output variable we want to request from the Energy Plus while it's running. What we can do is set up a custom simulation output and output name. Let's try to connect to simulation parameter. It requires simulation parameter. There's another component called simulation parameter and simulation output. Okay, simulation parameter. Now let's rerun the simulation. Now this time it will give us this unmet hour result directly. How can we get this result? Should be read custom result SQL file, and the name is this guy. So we have the output. Yes, we don't need this anymore. We have the hourly data. I just want to visualize that. We can do hourly plot. Where is the hourly plot? And let's minimize the class order. We can visualize it. Flatten the data. I think it's overlapping. You can see. Let me hide the room first. This is overlapping with the graphic. Now we have two charts here. The first one is a heating set point normal time. It's every hour, because it's all zeros. You cannot really see any difference. You can see the cooling normal, because we don't have a cooling system inside. So you can see most of this warm season is not comfortable, because it's showing 1. The hour is not comfortable. And I just wanted to prove this system works as expected, because there's no unmet hour for the heating system. It's kind of too good to be true. So let's try to run a quick test. Let me disable this first. Let's create a system availability schedule to turn off the heating system for some hours. Let's say if the ambient hour responds to that change. We can go to the Ironbug tab. How can we set up this? How can we turn off the system? First of all, we can go underneath the 00 Ironbug tab. There is an object parameter, and this guy can basically read the inputs of each component. Once you connect to the component, it will give you the inputs. So these inputs are what you can find directly from the, I believe, the Obsidian input and output reference. It's the same thing. And now you have each descriptions, like what's the availability schedule. It's basically 1 and 0 values for every hour. And if we want to do, let's say we have a schedule here, Ironbug schedule, tab Ironbug schedule. And the rules can be, so basically you can create as many as rules as possible as you want, or you can use one value to create for the whole year, or you can use 24 values for each hour over a day, and it applies to the whole year. Now I'm going to create a 24 list. Let's say 0, 0, 0, 0, 0, 0. How many zeros? Let me copy. Let's do a simple way. So 17. 3. Okay. 24. From 0 to 23. We have total 24 zeros. Let's say we only want to turn on the heating system on the hour of 1 to 3. So we only turn on the 3 hours of a day and throughout the year. Let's see how the mid-hour responds to this schedule. Okay. Now let's rerun the simulation again. Let's check the system, the result. So I think we don't have to check the cooling mid-hour for now. Let's only look at the heating one. If you see, we turn off the system. 0 means off. We turn off the system at 12 a.m. and turn on at 1 to 3 a.m. So 1 to 3 a.m. here. You can see at the hour of 1, it's not completely comfortable. It's like 30-40% hour is comfortable. What does that mean? It's okay. It's probably the time step. Let me verify this if it's correct. Okay, right now we have time step. Every hour we run 6 simulations. What if we wanna generate this value mid-hour for every 10 minutes? So yeah, every 10 minutes is 6. So time step is 6. Report frequently. Let's choose the time step, same time step. So you can see the description here. We can just generate annual, which is only one value, monthly, daily, hourly. By default, I believe it's hourly. That's why we have every hour value. And the last one is a time step. Time step is 6 steps per hour right now. By default, let's plug into time step and rerun again. Okay. Now we can probably see it's more in detail. Yeah, okay. Let me turn on the preview grid. This guy publishes the first hour. This is 1 a.m., 2 a.m., 3 a.m. 4, 5, 6. Okay. So during the 1 a.m. there are few hours. It's not first 30 minutes like this day. First 10, 20, 30 minutes is not comfortable. It is because let's check the weather file, right? We have the weather file. It's probably too cold. Import type of temperature. So during those hours, it's very cold. Yeah, you can see that. Or another way, we can check the room air temperature, just for the reference. And how do we get the room air temperature in this case? Room honeybee, the output, simulation output. I believe it's inside Confluent Magic's toggle to true. Room mean air temperature. We can use that one. It's fine. Okay. And we use this one as a base simulation output. And we can get the result from read room comfort result. Air temperature. Air temperature. Pattern. Okay, let's visualize all of them together. Now you can see it's one-to-one matching. These hours, you can see it's here. Because we didn't turn on the heating system at 12 a.m. So we only turn on the system. So these 3 hours turn on. That's why we can say it's much warmer. Temperature here, it's probably about 15, I guess. Here. And the first 30 minutes, I guess it's too cold. And the system takes some time to supply enough the heating for the room. Yeah. All right. Now we have this done. Let's turn off the system. We don't really need to run this time step for every 10 minutes. Let's delete that one, and let me clean up a little bit here. Okay. Now we have the ambient hour. Okay. Now we have the system makes sense. We know how to set up the availability schedules. Let me just unplug because this is only for testing. I'll just move it here, and the input.